Hey everyone, welcome to Student Algorithm. So in this video we're going to discuss about the bit manipulation tricks. So we will be covering about the 6 major topics. First thing is finding the values of A. Like we'll be performing the different operations like OR, AND and XOR with the A, and we'll be drawing some conclusions after doing these operations. You'll be understanding this after seeing the table that I have in the next slide. So the second topic that we are going to see is left shift and right shift operations. Like what exactly the left shift and right shift operations mean, and then we'll be seeing the programs of binary to decimal conversions and decimal to binary conversions. Then fifth topic is finding the given number is power of 2 or not. We'll be giving certain number, we need to find whether the given number is power of 2 or not. We'll be writing the code for these as well. Like we'll be starting from the brute force approach, and then we'll be moving to better, and then we'll be writing the best code. So then the last and final topic is swapping the two numbers. Like we have seen, like we know how to swap the numbers using the third variable, but using the bitwise operation XOR, how we are going to swap the numbers like A and B, let's say. So now let's get into the video. First and foremost topic, we are going to perform certain operations with A. The operations are OR, AND and XOR. Now let's analyze it in deeply, right? First thing, A or 0. Like let's consider A can be any number. Like for suppose let's consider A will be 5. If A is 5, the binary representation of 5 is 101, right? If we perform OR operation on this, what will be getting? 101. I mean the same number, which is equals to A. Similarly, if you perform this operation, let's consider the A operation for 4, 100, and then if we do the OR operation, we are getting what? We are getting 100, which is again equals to A. So when A is performing OR operation with 0, the answer will be equals to A itself. Got it? Now let's move to the A and just a minute here. Now let's move to the A and 0. Like let's consider A again. Let's consider A as 5, 101, and we are performing with 0. Right? What happens if we perform A and 0? As we discussed in the earlier video that I have posted, A and 0, like 1 and 0 will be gives to 0, 0 and 0 will be gives to 0, and 1 0 gives to 0. So then that will be equals to 0. Anything that will be performed with A and 0, that leads to 0, right? Now let's move to A XOR 0. Like we have took 0 and performing operation on A of XOR operations, right? Let's consider 1015, and then what we supposed to do? We supposed to do XOR operation. When we perform the XOR operations over here, we'll be getting 1 0. What will be that? That will be 1, because different numbers give the 1 and same numbers will be giving you 0. Then 1 0 will be 1, and that will be equals to A. Till now what we have understood, we have understood that when we perform A or 0, that will be resulting to the A. If you perform anything like AND operation with 0, then it will be resulting to the 0, and if you perform XOR operation with A, then that will be resulting to you A. So we have seen this observation, right? Now let's move to the A or A. Like for suppose let's take A is equals to 5 again, or any number you can take and you can perform the operation. If you perform OR operation, I'm just writing this is OR operation. 1 or 1, that will be 1. 0 or 0, that will be 0. 1 or 1, that will be 1. Let's again analyze with 4. to make it conform. What we are getting? 0 or 0, 0, 0 or 0, 0, 1 or 1, that will be 1, which is again equals to A. Got it? When we perform the same operation of with same variable or operation, that will be resulting to the A, right? Now let's move to the other, A and A. What exactly happens? Let's consider 5 again. We have 1 0 1 and 1 0 1. If we have this like 1 and 1, that will be 1, 0 and 0, that will be 0 again, 1 and 1, that will be 1. So we got A and A is equals to A. Now let's confirm this with 4. 1, you can take any kind of numbers and you can test it, the result will be the same. Okay, fine. We have 0 and 0, that will be 0, 0 and 0, that will be 0, 1 and 1, that will be 1, right? So that will be equals to A, right? Now let's move to the third operation over here, A XOR A. This is very important. Listen to this. Let's consider the same numbers, 1 0 1 and 1 0 1. In XOR operation, if the numbers are same, then the result will be 0. If the numbers are different, then the result will be 1. Here we have the same numbers, we are performing this operation, like 1 XOR 1, that gives to 0, 0 XOR 0, that will be gives to 0, 1 XOR 1, that will be giving you 0. So what we have concluded here is, if we perform the same operation, same numbers XOR operation, then the result will be 0. So then that will be equals to 0. Oh my god, just a minute. Okay, fine. Now let's perform with 1. Okay, now let's consider 1 0 1 and 1. Okay, 1 over here. So now we are performing OR operation. So 1 or 1 will be 1 0 and then 1. Now let's confirm with this 0 0 1. So 0 or 1, then that will be equals to 1, 0 or 0 0 and 1. What? This is some leading to confusion, right? Here we got 1 0 1, here we got 1 0 1. So the problem is, when we perform A or 1, it giving you two results, one for odd number and one for even number. For even number, it's giving you A plus 1. For odd number, it's giving you A. Like if you perform 0 or 1, and it gives you different result, and for odd number it gives you different results, right? And then let's move for A and 1. So what is this A and 1 tells? Okay, fine. Now 1 0 1 0 0 1. Now 1 and 1 gives you 1 0 0, anything with 0 0. So again we'll confirm with 4, 1 0 0, and then we have 1 over here, right? Then it gives you 0, 1 0 0 0 and 0. So for odd numbers it's giving you 0, for even numbers it's giving you 1. For even numbers it's giving you 0, for odd numbers it gives you 1. So remember that. Next, let's move to A XOR 1, like 1 0 1 0 0 1. Now let's perform XOR operation. 1 1 0 0 0 0 1 0 1. So what it giving? 1 0 0. We perform with even number. We'll see what it gives. It is different number, right? So now we have 1 over here, 0 over here, and 1 over here. For even number, it giving you a plus 1. For odd number, it is giving you a minus 1. So for the entire revision, we'll just revise it and then we'll move it, right? So firstly, we have seen A or 0 is equals to A and 0 equals to 0, A XOR 0 is equals to A, and then A or A equals to A and A is equals to A XOR A equals to 0. And for 1, when we perform the operation with 1, then there will be two different results, if A is odd and if A is even. If A is odd, A or 1 is equals to A and 1 is equals to 1, A XOR 1 equals to A minus 1. If A is even, A or 1 is equals to A plus 1, A and 1 is equals to 0, and A XOR 1 is equals to A plus 1. This is what we have observed. So now let's move to the left shift and right shift operations. So what is exactly the left shift and right shift operations performing in this, in problem solving? Now let's consider just a minute. Okay, now let's consider something interesting. Okay, we have this binary representation. Left shift is nothing but we will be moving everything to the left, right? So if we move everything to the left, what exactly happening? The value is increasing, right? The value is increasing. So whatever will be moving to the left, it is increasing, the power is increasing. For suppose I have the 1 0, now I am moving like 1 0 0. What exactly happened? The value of left shift of this increased or not? Absolutely, it is increased. So it is nothing but when you perform certain shift operations, we will be multiplying with 2 power I. Like for suppose I shifted this one time, if I is nothing but the number of times that you have shifted. Like for suppose if I shifted this one time, 1 0 is nothing but 2. If I shifted this for one time, it turned into 4. I mean 2 into 2 power I, right? This is 2 into 2 power I. 2 power I is nothing but the number of times I have shifted. I have shifted only one time, right? So that's why it's 2 power 1. Then the result will be 4. If I shift for 2 times, then it will be what? Then it will be 8. So similarly, when you shift it to the left, the value increases, right? If the value increases, we need to multiply with 2 power I. For suppose if I shifted 5 2 times, then what is the value of it? 5 into 2 power 2, because I shifted 2 times, then the answer will be 20. Got it? Similarly, for right shift, as we are moving to the right, the value decreases. This is a converse of left shift. Like for suppose we have 1 0 1 0 1 0 0. Let's consider we are moving it to the right, so the value becomes 1 0, and the remaining will be filled with 0, as we discussed in the last previous bitwise manipulation playlist, right? So it turns into 0 1 0. So after it turns into 0 1 0, the 4 1 0 0 is nothing but 4, it equals to 4. Now it turns to 2. Now what happened? Nothing but 4 divided by 2, that gives you 2. whenever if you move certain thing to the right side, it will be divided by 2 power I. I is nothing but the number of times you have shifted. I shifted here one time, so that's why I am dividing 4 by 2 power 1. If I shift 2 times, that becomes 0 0 1, so that is nothing but 4 by 2 power 2. 4 by 4, that is nothing but 1. So in this way we can find the exact values, like how many times the right shift happened, how many times the left shift happened. If you know the power high, then we will be multiplying or dividing based upon the shift. If it is left shift, we will be multiplying the certain number into 2 power I. If it is right shift, we will be dividing that particular number with 2 power I, where I is the number of shifts that we have done. I hope it is clear, right? Now let's move to another and next thing is binary to decimal conversion code. This is simple, easy. Now first we talk about the brute force approach. Brute force approach is nothing but we have the binary representation. Let's take 100 as a number. Now we are converting this into the decimal number. So how we exactly do is, we know that we will be representing this in 32-bit form, so the numbers that will be last will be 32 itself. So 100 we have done, we have written this, and we will be writing this in the form of decimal form. I mean binary number to decimal form. So now what exactly we know? We have seen the conversions, right? What we have learnt over here, we will be taking this and we will be multiplying with the power of 2 into 2 power 0, and we'll be taking this and 0 into 2 power 1. We'll be taking this 1 into 2 power 1. So now what we exactly need to do is we need to convert this into the code. So I will be telling the brute force approach. You just write the code over there, because this is the assignment for you. Now we're gonna discuss about just a minute. Okay, fine. Now we are going to dry run the binary to decimal conversion code, right? Let's take an example 101. Okay, here first d is equals to 0, n is equals to 101. All right, so now what exactly happening? Now decimal equals to decimal left shift 1 or n modulo 10. So decimal left shift 1 means shifting of 0 will be 0 itself, and then n modulo 10 101 modulo 10 will be of course 1. The last digit will be 1. So if you perform OR operation, we'll get 0 0 1. That is nothing but 1. So therefore now this is n, right? Okay, now d is turned to 1. After converting decimal, now we are converting n. So n equals to n divided by 10. So now 101 divided by 10. What it gives? It gives you 10 again. We should not consider the points after the 10, right? So then n is equals to 10. After this, now let's continue with decimal, finding d. So now d is equals to, we got 1. Again we need to left shift 1. After left shifting 1, we'll get 1 0, which is equals to 2. And then we need to perform the OR operation with n modulo 10. Now n modulo 10 modulo 10 will be equals to 0, right? Now OR 0, that will be equals to 1 0, which is equals to nothing but 2. So therefore now d is equals to 2. N equals to 10 divided by 10, which is nothing but 1. Got it? Now let's this will be the last step. Now d is equals to, we need to left shift this. So now 2 left shift of 1, that gives you 1 0 0. Now n modulo 10 is nothing but 1 here. So now 1, then that will be equals to 1 0 1, which is nothing but 5. So now D is equals to 5. Now n should be divided by 10, right? So then that n is equals to 0. So this will be running while n should be greater than 0. So now here n became 0, therefore the loop will be started, and after that we will be returning the decimal value. So therefore the decimal value will be equals to 5. So this is the simple code that we have written. Now what is the time complexity here? The time complexity here is inside the loop, what we are doing, we are dividing by 10. Every time it is divided by 10. It is divided by 10. Therefore the time complexity will be equals to log base 10 decimal here nothing but n. If we represent this in n form, then that will be equals to log n to the base 10. This is your time complexity. Space complexity will be 1 because we are not using any data structure to store any elements. We just use this constant variables to store some elements. Now your assignment work is, there is a best approach using libraries. You have chosen certain language, right? Java, either C++ or Python to code. In your particular chosen language, find the useful libraries where we convert the binary to decimal conversions. Alright, so now let's move to the decimal to binary conversion code. So in this, what we have done is, okay, let's consider the decimal number over here. We took 5. As we know that any decimal number or any number that will be stored in the form of 32-bit, right? Whatever the number you will be taking, the number is stored in 32-bit format, right? So here we took the number 5 in 32-bit. So to convert this binary number to the decimal, what we are doing is we are just looping from 31 to 0, like from backwards to the front. So what we are trying to do is, okay, fine, now we have n is equals to 5, right? So what we are trying to do is we are printing it. We directly printing it rather than storing. So or you can store it in a string, or you can store it in a array. So if you want to directly print, you can also print it. So in this, what I am trying to do is, here have for int I is equals to 31, I greater than or equals to 0, I minus. So first I equals to 31, right? So basically here I have 5. So 0 1 2 3 4 5 6 7 8 9 10 and so on. I will be having here 31, right? So this 31, what I'm doing, I'm shifting n. So this is n, right? I'm shifting n how many times? 31 times first, and I'm comparing with and 1. So why we are comparing with and? Because for suppose we have 0 and 1, that will be 0, 1 0, that will be 0, 0 0, that will be 0, and then 1 1, that will be 1. To know whether the particular digit is 1 or not, we will be checking with and. Like for suppose we have 0 1, that will gives you 0, 1 1, that will gives you 1. Why we are not doing with 1? Because if we'll be doing with 0 or 1, it will give you 1. That's why to check whether the bit is 1 or not, we will be using and, right? Getting my point? So what we are trying to do is, we will be trying to perform and operation after shifting it. So it will be printing 0, and then for 30 n will be right shift, it just shift how many times? Next 30 times, then it will print 0. It shift 29 times, it will print 0, and so on. It will shift 3 times, it will print 1, 2 times 0, and then 0 times 1. So in this way the entire 5 is printed, right? So now let's move to the next topic, like the best method. See, previously we didn't discuss about the time complexity. As it is taking 31 times, it will be considered as big O of 1 itself. It doesn't consider as big O of n, but as it is following the 32-bit operation, it following the constant time. So the space complexity is, we will be using the array. So then that if the size of the array is n, then that will be 32, whether it is also a constant space, right? Now let's move to the decimal to binary, conversion code. The best approaches you need to find out, right? Using the standard libraries, you need to find out all those things. And then now let's move to the power of 2. Power of 2 is nothing but, if it is nothing but just, we have taken several numbers like 4, 8, 2, 6, etc. So the power of 2 is nothing but, if 4 is a power of 2, because it can be written in the form of 2 square is equals to 4, 8 is a power of 2 cube is equals to 8, 16 is power of 2 power of 4 is 16. Whatever the powers are there, like 2 power 0, 2 power 1, 2 power 2, 2 power n, these are all nothing but the powers of 2. Got it? 6, it is not a power of 2, right? 12, it is not a power of 2, because we cannot write it in single form. Like we can write it in the form of 2 powers 4 plus 2 power something like that, but we cannot write it in directly form, right? So how we need to find whether the given number is power of 2 or not? Using loops, of course, using loop. Now keep dividing the number by 2 until it becomes 1. Like suppose you have given 18. Let's consider you have 18. Now you need to divide it until it becomes 0. If it becomes 0, and then like exact 0 if it becomes, then of course it is nothing but it is a power of 2, right? Try to write a code for this and try to find a time complexity and space complexity. This is your assignment. And now next move to the power of 2 best approach. Let's take a few numbers. Let's take 7, 8, 15 and 16. Okay, now we have 7 over here. We'll be writing it in the form of this. We have 8 over here. So whenever we perform AND operation, you'll get 0. No matter what, you'll get 0. If you perform the AND operation between this, you'll get 0. Let's analyze for something else. Like let's analyze for different numbers. Let's take 4 and 5. Let's take 4 and 5. 0, 0, 1, 0, 1. We'll get some other number like 1, 0, 0. Whatever you perform, that will gives you 0 to determine if it's power of 2 or not. For suppose we have n, like we have 8 and 7, that represents you 0, which means 8 is a power of 2. Got it? You once try to code it. It's simple. You need to take input. I'll be showing you. You need to take input and you need to check or return if n is greater than 0 and n minus 1 is equals to 0, then that will be a power of 2, right? Next we'll be moving to the swapping of 2 numbers. We all know swapping of 2 numbers using temp variable. Like we have a is equals to 10, b is equals to 5. Right? So how we will be swapping these numbers? You need to take a temporary variable c is equals to, we need to initialize a, and then we need to transfer b to a, and then b is equals to c. Got it? First we cannot initialize a is equals to b and b is equals to a. What happens if we do this? If you do this, firstly a will be storing the b value. Now b will be storing again b value. The a value will be disappearing. So that's why we should not follow this approach. The most significant, most useful approach is they will be taking a temporary variable, they will be storing a, and then they will be converting, they'll be storing b in a, and then temporary variable in b. So this is how we will be performing. So now without any temporary variable, how we gonna how we are shifting or how we are swapping the numbers. Let's see. For suppose we have here a is equals to 10 and b is equals to 5. So what I'm trying to do is, generally I'm trying to take a is equals to 10 plus 5. I'm adding both, right? Now b is equals to a minus b. What is a now? A is 10 plus 5. What is b now? 5, right? Now what is a? A is equals to 10 plus 5. What is b? What is b now? Here if we cancel 5 and 5, you'll get b. Now minus 10. So you'll be cancelling this and this. So therefore your b value becomes a and a value becomes b. This is how you are gonna swap the numbers. Like what we are doing is, we are storing a value and we are adding the both the values into the a. So now if a is equals to a plus b, right? And then in b value we'll be storing a plus b minus b, then plus b minus b will be cancelling and a will be storing. In a what we are doing, a minus b and then minus a. What we are doing, we are cutting these a's and the b will be storing in what will b will be storing in a. This is how we are swapping the two numbers. I hope you got the logic. Now let's move to the swapping of two numbers using XOR. We will be doing this with XOR operation. Now let's consider the same example. Now let's consider a is equals to 10 and b is equals to 5. Got it? So now a is equals to 10 XOR 5, right? B is equals to, what is a here now? A is equals to 10 XOR 5 XOR b. What is b? B is equals to 5. So now what happened? A XOR a is equals to 0. It will be giving you 0, right? So this will be and this will be cancelled out. Now see, a is equals to, what is a? A is equals to 10 XOR 5 and XOR 10. Now exactly this and this will get cancelled. Now a will be storing the b value and b will be storing the a value. This is similar to the plus and minus operations that we have done in previous slide. So what we have discussed over here is, simply if we have same numbers, then that will be turning up to 0, and anything with XOR is equals to that number itself. That's why this plus and minus and XOR symbols swapping is similar. Got it? Now let's try to revise what we have learned. We have just went through what is a with a 0, a1 and OR and XOR. So what will be happening if we perform with various operations, and we'll be getting some conclusions. We have drawn that conclusion and we have understood that. And next we went to left shift and right shift, and next the conversions, binary to decimal conversion and decimal to binary conversions, and we have written the codes for better approach in XOR bitwise operators. You have to write brute force, and as well as you need to find out some standard libraries that will be useful for these conversions. And later we went for power of 2, how this power of 2 will be happened, and then lastly we'll be went for swapping of two numbers, how this exactly the two numbers get swapped using plus and minus and XOR operators. So this is all we have learned. And then you have some certain functions or libraries in your particular chosen language you need to know. In Java we don't have any swapping function. In C++ we have. In Python we can directly write a comma b is equals to b comma a. So there is no issues. So this is all about today. Until then, keep learning. We'll be posting the videos continuously. So until then show some love. Bye bye.